Hello dear students, I welcome you in this video clip series on the concepts of physics. And today we will do our first concept, which is the concept of mass. Now to begin with, I ask you this question, what is mass? So what would be your answer? The quantity of matter. Now I ask you the question, what is matter? Now you will see that you will be caught in the cyclic definition. This is not the way we do physics. In physics, when you define something, we must have the operational definition, which means that we must know how to measure the particular idea that we are proposing, right? So if I mean mass, I mean I need to have it as operational definition, which means that I should be able to measure it. So Newton had two ways of measuring the mass. So there were two operational definitions, and let's try to understand those two operational definitions. The first is the mass of inertia. What do we mean by mass of inertia? It's very simple to understand that I have a body and I apply force on it. It will try to resist this external force. And how much it resists that external force is called the mass of inertia. That means if a body is very massive, it is very difficult to change its state. And naturally, and therefore its inertial mass is very large. And if a body is light, it is very easy to change its state of rest. That means its inertial mass is small. Right, so this is how you operationally measure mass. Remember, there is no direct way to measure mass. It's only measured through its interactions. Now, what was the other definition of the mass? Now we know that Newton also knew it, that the earth pulls everything towards it, right? So everything is pulled by earth. For example, this bottle is pulled by earth, fine. So they pull that earth exerts on a body measures its mass. A heavy body experiences more pull, therefore it has more mass, and this mass comes it's like charge, like electric charge is the charge. It tells us how quickly the body will how strongly the body will experience the electric field. Now this mass, which tells us how strongly a body would experience gravitational field, is called a gravitational mass. It's more like gravitational charge, right? That means how much a body experiences gravitational force. That's called the gravitational mass. So its gravitational mass is a property because of which two bodies interact or apply force on each other, whereas the inertial mass is something different. It is the property by virtue of which a body resists the external force. So therefore there are two operational definitions of mass. One is the gravitational mass, which is the mass that is due to the pull of the earth, and the other is the mass that measures how much a body resists the external force. And these two masses, they look different, but when experiments were done, for example, in a simple pendulum experiment, both the masses will come up. For example, earth pulls the simple pendulum, and it's the component of the force that pulls it back to the mean position. So the external force is the force of gravity, which will contain the gravitational mass, and it will now react to that gravity and will move with some acceleration, and that how much it yields to the gravity is measured through its inertial mass. And when you calculate the time period, we figure out that these two masses exactly cancel out, and there is no experiment which can tell us there is a difference between the two masses. Newton, he knew that these masses were equal, and experiments after him were also done. A lot of experiments there where the people try to figure out there is difference between the two masses, but they reported only null results. What Newton did not know is that why these two masses are equal. So that was the philosophical drawback, that we do not know why they should be equal. We know they are equal. The experiments tell us that gravitational mass is equal to the inertial mass, but we do not have a mechanism why they are equal. And we had to wait for this answer, that why these two masses are equal, till Einstein arrived in around 1915. He proposed a great idea that these two masses are equal intrinsically, and there are no two masses. That gravity is not a force. Gravity is not the force the way Newton thinks. And he explained that how inertial mass and gravitational mass are actually equal, and there are no two masses. Since they are equal fundamentally, and therefore there would never be an experiment which will tell us the difference between the two masses. Not only he clear this confusion that there are no two masses, he also scratched another real of reality, another layer of reality, and that was that mass is energy. So he proposed another operational definition of mass, that one can measure mass in terms of its energy, the famous E equal to mc square. In the modern physics, what's called as particle physics, there is another deeper layer of reality, and that at first place, what causes this mass to happen? At first place, why? What is the mechanism that bodies acquire this mass? Right, according to the standard model, the fundamental particles, the leptons and the quarks, should be massless. But why they have mass? Because they interact with a field which is all pervading. That's called the Higgs field, and the mechanism is called Higgs mechanism. So when the particles interact with the Higgs field, they get this inertial mass by interacting with the field. So we understand why mass at first place through the field theory. So now you see that how the idea of the mass has evolved from inertial and gravitational mass to the mass in terms of energy, and then the mechanism of why the mass bodies have mass at the first place. I hope I have cleared the idea of what is mass. Please give your feedback, and in comments you can place your comments so that I can also have some learning experience and free feel to ask you questions. Like and subscribe the channel. Thank you very much.